I will be explaining here 2 implies 3. Okay, the theorem 18.1. The theorem's 18.1's continuation. Okay, here I will explain you 2 implies 3. So here what is mean by that? You are going to assume the second condition and you will prove the third condition. So assume this is the second one, this is the third condition. To prove this, okay, just copy it down from the question. So now what you are doing is let A is equal to F in, you are taking this F inverse of A is equal to F inverse of B. You are writing like that, okay. So now if you are taking A is equal to F inverse of B, what you have to prove? F inverse of B is closed in X, right? We are taking A is equal to F inverse of B, so you can say A is closed in X, right? That is therefore to prove A is closed in X, because in the above step you have took A equal to F inverse of B. So in the next step you can write, instead of putting F inverse of B is closed in X, you can write A is closed in X, because both are equal. That you took, right? So if you want to prove A is closed in X, we have to prove A is equal to A closure. Okay, so to say A is equal to A closure, these two if you prove these two conditions, then obviously A equal to A bar condition will be proved. So that is to prove A contained in A bar and A bar contained in A. That's what this line. Okay, that is clearly A contained in A bar. Okay, A will be contained in A bar, that is obvious. So here what you are going to prove is A bar contained in A. Okay, so to prove A bar contained in A, to prove A bar contained in A, what you have to do? You have to take a point from this A closure, that is X, and at the end you will say that X is also in A. If you say that, then this condition will be proved. If this condition is proved, then this condition is proved. If this is proved and this will be proved. If this is proved, then this will be proved, right? The required condition will be proved at the end, right? So that is what we are going to prove. We are taking a point from here. Let X belongs to A closure. Then what you are doing is you are multiplying F on both sides. F of X belongs to F of A the whole closure. Sorry, F of A closure. In our assumption we have F of A closure contained in F of A the whole closure. So from our assumption you are writing here F of A closure contained in F of A the whole closure. So from this line you can write F of X belongs to, combining this two you can write this line. Now keep that as equation number 1, because you are going to use it further. Now what you are doing is you are considering something, that is F of A. You are considering F of A, and this F of A can be written like this. How? F of, in the place of A you are putting the value of A here. Okay, F inverse of B. So from this you can write this contained in B. Okay, now implies, combining these two you are writing this line, F of A contained in B, implies you are taking closure on both sides, so that you get F of A the whole closure contained in B closure. Now equation 1 implies, you are writing equation number 1, and here you got F of A the whole closure contained in B closure, right? So you are writing that here. You are writing equation 1 first, and then F of A closure using this here, contained in B bar and B bar equal to B. That is how you are writing. Okay. Now implies, combining these two, last two, you will get this F of X belongs to B, and from this you can write X belongs to, you are bringing this F to this side, so that you get X belongs to F inverse of B. You know that F inverse of B is equal to A, right? That is what you are writing, and in the next line you are writing X belongs to A. So finally in the first line you took X belongs to A bar, and same X now you got, that is in A. So you have proved the condition A bar contained in A. So therefore A equal to A bar, so that you can say A is closed in X. So what is A? A is F inverse of B, right? So in the next line you have to write F inverse of B is closed in X. So your condition you have proved, F inverse of B closed in X. That is what we have to prove, right? So at the end you have proved it.